19. No. Unfortunately, no. Okay. For number 1, you needed to find whether this was a mapping. I'm sorry, if the mapping was a function or not. The answer was yes. Each of the x's go to one y value, so that would be a function. For number 2, you needed to solve the equation. So distribute, combine like terms, start solving for x, and after you do that, x would equal 3. For number 3, it asks about the domain of these ordered pairs. Remember, your domain is your x value, so you're looking for all of your x values. You need to write them least to greatest without any repeats. I don't think there were repeats in this one anyway, but -1, 0, 2, 3, 5 was your domain. Do we have any questions on those 3? Number 4, you needed to solve this for y. So add 2x on both sides, divide everything by 3, and you would get y equals 2 over 3x minus 4. And then in number 5, you really had to do the same thing, solve the equation for y before you could graph it. So if you subtract 2x on both sides instead of adding, and then divide everything by 3, you get y equals -2 over 3x plus 2. So we would start on this graph at 2 on the y-intercept, and we would go up 2 to the left 3 as many times as possible, and down 2 to the right 3 as many times as possible. Do you have any questions on 4 or 5? You all have new notes in front of you. This will be the next set of factoring in the unit. And it should look something like this. Okay. So before we get into the actual factoring piece, we're going to do these warm-up problems to show you what format these are going to look like. So if we had this, we would take this and distribute it, but we're going to do that twice. So I'm going to show you what that looks like. So if we take this first term and multiply it to everything in the second, remember that when we're multiplying variables, we're adding the exponents, and it doesn't say it has an exponent of 1. So x times x would give us how many x's? 2, but yes, x squared. And then x times -4 would be -4x. Then I would do the same thing to the others. Take this +4 and multiply it to the x and the -4 again. So this time we would have +4x and -16. Then we could combine like terms. What happens when we combine our like terms?
Both 4x's.
Say that one more time.
We remove both 4x's.
Yeah, so like they cancel out, they become 0. So when we combine these two, all that is left is just x squared minus 16. Let's do some of these others. Same thing, if I take 5m and I multiply it out, what would that give me? 5m times 5m. What would that be?
5m times what?
5m.
5m
M squared, yes.
It'd be 10m2.
Multiply. 5
25m2.
Here we go. 25m squared.
Why you talking like I'm stupid, Taylor? Shut up.
And then 5m times negative 1 would be negative 5m. And then I can take 1 and multiply it out again. So we would have a positive 5m and a negative 1. Just as before, when we combine our like terms, they would cancel. So we would be left with 25m squared minus 1. And then we'll do this last one and then talk through these steps. If I multiply 2a by everything in the second set, what would that be?
2 times 2.
That is 4.
A2?
A squared.
I like A2 better.
A squared.
So I can't say A2.
Not that you can't. The correct term is a squared. Or to the second power. Either.
Okay, I'll take it.
2a times negative 3b. What do we think that would be? Jake? Yeah. Negative 6ab. We're just adding on the variables at this point. So then if I do that to the others, 3b times 2a, even though the b comes first, I could still write it as 6ab. I don't have to write it as 6ba, but even if I did, those would still be like terms because multiplication is commutative, it doesn't matter. And then 3b times negative 3b. I heard negative 9. Negative 9. So when we combine those like terms, the middles cancel again, and we're left with 4a squared minus 9b squared. It is a little more complex because there's more variables. Okay. So what we just did is now what we're about to do. It'll look similar. We're going to be given this, something that looks like this, and we're going to go back to these. And I'm going to show you how to do that. So when we are factoring this way, we're looking for difference of squares. So that means 1, we're subtracting. It has to be subtracting, otherwise it's not a difference of squares. 2, whatever the first term is, has to be something that is basically a perfect square number or a perfect square variable. A times a equals a squared, that would be a perfect square variable. And then your perfect square numbers, 1, 4, 9, 16, 25, 36, 49, 81, 100, and continue. And they both have to be like that. The first term and the second term. So if all of those 3 things apply, you're going to look for, sorry, let me start over. You're going to have 2 factors. And you have to think about what times what would give you the first term. So in this case, what times what would give us a squared? A. So we would put a here and here. And then what times what would give us b squared? I'm ignoring the negative for a second. B. So we would put b here and here. And then the very last thing we need to do is put a plus and a minus in between them. Guys, this is going to go by really fast. Make sure you're writing this down. Before we do some actual examples, does anyone have questions on that part? Now, I am gonna do this last part, but we don't need to distribute every single time. If you know that if you know everything is correct. But it is a good check method. So if I were to distribute this back out, a plus b, a minus b, a times all of this would be a squared minus ba or ab, doesn't matter. And then b times all of this would be plus ba minus b squared. Those would cancel, leaving a squared minus b squared. So that does work. You could always distribute it back out to see, did I do this right? Did I get the correct numbers? For number 1, is 4 a perfect square? Yes. A squared is a perfect square variable. We're subtracting. So we can start off with our 2 factors. What times what gives us a squared? A. And what times what gives us 4?
2.
2. And then for the plus and minus. Does not matter which one comes first. You can have minus or plus.
Why you do plus and minus?
Because we have to have, if they were to distribute back out, they need to cancel. So that we get our difference of squares.
Wait, but wouldn't that cancel out just 2's? How would that cancel
It
out?
would cancel out the 2 A's. Like if I were to distribute this back out, we have A times all of this. So off to the side. We have A squared minus 2A. And then 2 times all of this would be plus 2A minus 4. The middle terms are getting canceled, leaving just A squared minus 4, which is what we have.
Oh.
So if we don't have plus and minus, that won't work. Maddie.
Distribute
His hand is
in the parentheses.
Yeah, so there are different ways to write this one. Hold on one second. If we had a whole unit on like exponents and things like this, we would talk about this, but we don't. So the reason we can do this is because we can rewrite these parentheses. Because since I distribute it like this, I can say this is the same thing as a times a minus 2 plus 2 times a minus 2. So I'm distributing twice, but it looks different. But this and this are the same thing. It's just how we distribute it.
I just running like that.
Sure. Sure. And again, the distributing part is just to check yourself. You don't even have to do that part. Number 2. We have perfect square variable. We're subtracting. So what times what will give you n squared? What times what will give you n squared? N. And then what times what will give you 64? We have plus and minus, and that would be our answer. Again, it doesn't matter where you put the minus or plus, whether you put that first. However, the order in which you put the variable and the number may matter depending on how it is originally, like in number 3. You're still doing the same thing, they're just in opposite order. So for this one, what times what gives us 81? 9. So in this case, 9 would go first. And then what times what gives you x squared? X. So it would just be flipped. Same process, just flipped. Okay, before we continue and do some more, do we have any questions on this so far? Let's jump to number 5. Willow, what are you answer?
So now I'm just gonna say the answer.
Yeah, go ahead.
Nine.
That one is prime. Someone tell me why.
Well, what?
Why number 5 is prime?
Is what?
Prime, Prime.
Because it's a
Because it doesn't don't have the plus and the minus.
Well,
It would have to like positive.
that we wouldn't be able to factor it because we don't have the minus to make it the plus and minus, yes. But bottom line, it's plus and not minus. So this would be prime. Cannot be factored. To be careful with things like that, make sure you're paying attention because there might be some like that when we get to the quiz, the test, where you think it's going to be like k plus 5, k minus 5, but it was plus, so it was not supposed to be factored at all. Okay. Let's do number 6. Okay. So it's the same process, but now we have a little bit more added to it. If I took the square root of both of these, what numbers and variables would I have in here? Or what times what gives me 1? What times what gives me 49? What times what gives me y squared? Repeat it. 1 plus 7y, and then the other one? Correct. So just because it has more to it, you're still doing the same thing. Maybe do it step by step. So 1 times 1 gives me 1. 7 times 7 gives me 49. Y times y gives me y squared. And break it down like that. More. I had something like number 9. You may have to think about your perfect square. But what would your 2 factors be? 4a plus 11 and 4a minus 11. 4 times 4 gives you 16. A times a gives you a squared. 11 times 11 gives you 121. What about 12? What would our factors there be?
B. And pretty sure it's 8.
8 and u, and then the v for the n, yes. And then plus or minus. Do you have any questions so far
Nope.
on any of this later? Yeah. Move to the next page. Now a lot of these are similar to what we just did, but also a little different. So like for number 13, we now have 2 variables in the first term instead of just 1. Same thing though. What would my 2 factors be?
X or Y?
Xy plus 1 and and xy minus 1. Now, if you look at some of these other examples, what happens if our variable is no longer squared? As long as your variable exponent is even, you can divide it by 2. So for 14, if I were to divide that exponent by 2, I would have n squared. You know, 9 times 9 gives us 81, so we have 9n squared plus 5 and 9n squared minus 5. So when you have something that's higher than 2, we're still going to do that. Just divide by 2 to your exponent. Before we do another one, I want to show you an example of something you might have to do this twice with. Somewhere where you have blank space, write this down. (81) w to the 4th minus 1. What would our two factors from this be? 9w squared plus 1 and 9w squared minus 1. Normally, when we get these, that's it, we're done. However, if I look back at this difference factor that we have, 9 is a perfect square, w is a perfect square variable, and 1 is a perfect square. So we would need to factor that again. So just looking at my 9w squared minus 1, what would that be when we factor it again? 3. Which times what gives us w squared, w, and then 1. So with this one, instead of just having 2, we would actually have 3 factors because we would need to put all 3 of them. So if you get an example like that, make sure you're double checking, I cannot factor this anymore. The inside is prime, or I can't do any more difference of squares with it, something like that. Okay.
Would the answer be 9w squared plus 1 and then?
The order doesn't really matter.
Okay.
I can put this on the outside of this, that part doesn't matter.
Wait, but like, do you have to include 9w squared plus 1?
Yeah, all of this is the answer. Other questions on that?
No, that's not right now. Wait, where'd you get 3w plus 1?
When we're looking at 9w squared minus 1, we can break that down again.
Oh.
Because 9 is a perfect square and 1 is a perfect square. Yeah. For number 17. What would our two factors be? Remember, if your exponent is not 2, you need to divide it by 2. So k to the third, yes. And k's look weird, but they are k. and 4. So k to the third minus 4 and k to the third plus 4 would be our answer. Let's do number 20, and then I'll let you guys practice for a bit, and then we'll come back, and then we'll talk about the last one. So for number 20, what would our two factors be? 8m squared plus 3n, and then minus 3. Do we have any questions before I let you guys go practice some? So the ones we did not do up here,
Is that K?
just pretend it's a guess. It is supposed to be one. The ones here we did not do, as well as the ones on the first page we did not do. Go through those. I'll give you 5 to 10 minutes to do those, and then we'll continue with our notes. Number 4, C plus 10, C minus 10. Number 7, 3b plus 10, 3b minus 10. 8, 5k plus 7, 5k minus 7. 10, x plus 9y, x minus 9y. 11, 2h plus 5g, 2h minus 5g. Do you have any questions on those before I flip to the back? $15 was prime. Had the 5 been a 25, then we could have continued that one, but that one was prime. 16 was 7m squared plus 4 and 7m squared minus 4. 18 was 11r to the third plus 1 and 11r to the third minus 1. I'm sorry, that was 19. 18 was 2p squared plus 5 and 2p squared minus 5.
So why is it prime?
Because 5 isn't a perfect square. If it was 25, then that would have worked. But 5 is not. 5 does not work. Other questions on those? So now we're going to take this just one step further. So now we're going to look and see, still do that same process, but we may not be able to start that process immediately. We may have to look at it and see, is there something I can maybe divide out, and then maybe I can do difference of squares. So let's do some of these. For number 21, are either of these perfect square numbers? No. So if that's the case, look and see, can you divide out like a DCF? Do these two have something in common? Yes, what? 2. So we can, divide both of these by 2 and see what's left. If we divide these both by 2, what is left? N squared. And minus 36. After you get to this point, you need to ask either, can you divide out anything else? So can we do that? can you divide something out of both of them, like the same number out of both of them? No. So we don't have another GCF. If that's the case, then you can ask, can we do difference of squares? Could we do difference of squares with this? Yes. So with that, you're going to bring down the 2 that you factored out. It'll just stay, it'll like tag along. And what would these 2 factors be? And minus 6 and plus 6. So it's the same process as before, but with an additional step. "22. Can we start doing difference of squares right away? No. So we would need to find the GCF. Anyone know what that is off the top of their head? Yes. Does anyone know what it is for these 2 numbers? I should have been more specific. For 18 and 50. If you're not sure, you could always go back to your factor tree. So off to the side, I'm going to do that really quickly. What are some factors of 18? 1 and 18. 2 and 9. What about for 50? 1 and 50. 2.5. There's 1 more 5 and 10. And I believe that's it. So of these, what is the highest GCF? 2. Not a really big GCF, but that's what our GCF is for this one. So if we were to divide 2 out of both of these, what would be left? Not, sorry, I heard X. What was the number before that? Not 3.
9.
9. And then when we divide 50 by 2?
25.
25. Using what? The difference of squares. So if we reduce it again, what would those 2 new factors be? 3x minus 5 and 3x plus 5.
For these problems, you have to. Wait, it doesn't matter if you do 3x plus 5 or 3x minus 5.
No, that part does not matter. The placement of any of these doesn't really matter. I could put 2 at the end of this. It's just easier if you put it at the beginning, because then you don't lose it. Okay, do we have any other questions on these before we do a few more? Jumping to number 24. These are not perfect squares. So we have to take something out of both. Does anyone know what that number is off the top of their head? 5. And these also aren't perfect squares because we have 2 to the third and we have just q. So they both have a q in common. So we're going to take one out. So if we divide both of these by 5q, what's left? 1q squared Could we break that down again? Yes. Five Q on the outside, 3Q plus 2, and 3Q minus 2. Let's do another. 426. And you know what the GCF would be on the top of their heads. Those are bigger numbers, so we have to think about a lot more in common. Say that again.
1 and 100.
1 and 100. 50.
4.
25.
5.
5 and 20.
9.
That might work, but I feel like that's 90. But double check that for me. I know 10 and 10. Does that work? Okay. Okay, and then 36. 1 and 36. Say that one more time. 6 and 6. 2 and 18. And I heard 3 and I heard 4. With what? Four and 9. 3 and
No, that's fine.
12. Not that that really matters, because what is our GCF out of all of these? 4. So if we were to divide out a 4, is 4 the only thing these have in common? No. What else do they have in common? 10, 30, 8, yeah. So if we divide both of these by 4b, what's left? Use the factor sheet to help you if you're not using your calculator. 100 divided by 4 would be 25. We're dividing by b. How many b's do we have left? Squared. And then 36b divided by 4b. Nine, not the b. It's 9. And then if we break this down again, what would our two new factors be? 5, 5b, minus 3, and 5b plus 3. Almost done. Okay. So I feel like I mentioned this, but I'm going to re-mention it. When you're at home practicing this, or even when you have time to practice it now, or after we finish these last two, you can use Desmos. I just wouldn't be reliant on Desmos because you won't have it for the quiz, for the test. But if you were to use Desmos, for number whatever number it is, 27. Yes. And you open up your keyboard, go into functions, scroll all the way down to number theory, find GCD, which is greatest common divisor. You're dividing by something they have in common. So it's the same thing as greatest common factor. Then you can list the numbers that you have, so 80 and 125, don't put the negative. And it will give you what that GCD or GCF is without you having to do the factor tree. But doing the factor tree does help you and will be good practice. So we know our number is 5, but we have to figure out how many n's do these both have in common. How many would that be?
Ask the question.
How many n's do these two have in common? 2. So if we're dividing everything by 5n squared, what's left?
When? Is that for this one, or is that not for this one?
This is not for this one.
Oh, never mind then. Oh, wait. 16
16
and 25.
and 25 for the second one. What would your variables be for the first one?
And 2.
N squared.
And then the other one is n to the second power.
These n's would completely cancel.
Oh, sorry about that.
How would we break this down even more? -5, yes, and the n, not 7. 4. Remember, you're not dividing by 2. What will give you 16? It has to be the same. Okay. For 30, we can divide these both by 3. If we divide them both by 3, what's left?
You divide by 3
Yeah.
on that one, it's just n to the second power.
Yeah.
And then on the other one is, you'll have to give me a second. 49.
49.
You see that stuff? I'm a mathematician. It's genuinely crazy.
You all are mathematicians.
No, when I'm talking about myself. I'm not talking about everybody else. But
Got it. How would we break this down further? And -7 and +7. Good. Do we have any questions on this process? It's really the same as what we were doing before, but now there's an additional step because you have to divide out something they have in common. So for the next 15 or so minutes, you guys have time to finish working through these remaining questions. But before you do that, just another one.
so what? 5.
Okay, so let me get everyone's attention for just a second.
Okay. I'm ready.
For number 23, 2 times 4s plus 3u, 4s minus 3u. 25, 6 times 2a plus 3b, 2a minus 3b. 28, 8y, x plus 2y, x minus 2y. 29, 9p, 2p plus 1, 2p minus 1.
Oh.
And then 31, 4K, 2K plus 5, 2K minus 5, and 32, M plus 1, M minus 1. Okay. Those answers are